right, here we have with us Dr. Misha Pavel. Welcome, Dr. Pavel. We are really happy to have you here at ASE conference. So tell us something about yourself and your research.
I'm glad to be here, and my background is actually multidisciplinary. I'm both engineer, computer scientist, and psychologist. So I've been working at that intersection of those disciplines for many years. And the last 20 years I have been focusing on issues that have to do with healthcare, because that's one of the huge problems in this country and globally. And in particular, I've been looking at how technology can help elders to improve their quality of life and age in a healthy way. The general idea is that a lot of our problems in healthcare arise from behaviors.
That's true.
In fact, 40% of premature mortality is due to behaviors, and so those are changeable. Our genes we cannot change, but those are changeable. And so, can technology help? And the advances in sensor technology enable us to measure behaviors or observe behaviors in real life, in the wild, as we say. And we have been working on this new area we call behavioral informatics, which has to do with monitoring, inference, assessment, and intervention behaviors. And so the reason why this is big data is that you can monitor a lot of sensors, but all the sensors are sort of unobtrusive.
That's true.
And they are a little bit removed from the processes that you want to measure. And so you have to build sophisticated algorithms and analytics to figure out what's going on.
Makes sense.
Also, measuring in the wild, the context changes, and you have to be able to overcome that.
Makes sense.
So and that makes it hard. You have lots of data, and you have lots of potential situations, and you need to figure out what's important.
Makes sense. So where do you think the big data and biomedical engineering, biomedical research comes up in the next 5 years?
So, yeah, I have a very strong opinion about the sort of situation that we are facing right now in big data. A lot of algorithms that people have been developing, which I call black box algorithms, they're based on regressions. There are a lot of people who think, even sophisticated ones, that think that, oh, if you only have enough data, we don't need hypotheses, we don't need to understand where it comes from. Well, that's totally wrong. Because in order to actually intervene and figure out what needs to be done, you need to understand why it happens. And so my thrust is looking at ways we can develop models that combine data and principles
To make it understandable.
to make it not only understandable but really predictive. Because regression models are predictive, but only within the domain of the training set. But we want to have the ability to actually intervene with individuals, and for that we need to predict individuals. It's not enough to look at populations. So that's basically my general view of the big data. And as I mentioned, we have collected large amounts of data on fairly large number of homes, like 200 or 300 homes. I was in Oregon before Northeastern, and that's where we have done this. And now we have mobile technology, wearables, and we're collecting more data, but we need to build models that relate what the data are telling us, what the raw data are telling us, to what you want to know. So, for example, even measuring blood pressure, you're really not interested in blood pressure. That doesn't mean much. It's what it indicates about your health. It's the implication about your cardiovascular system.
True. That's very true, and that's a simple big data example. I should say that we really need to work on.
And this brings to another point that's very important: is variability.
Yeah.
So, what if when you go to a doctor, she will ask the nurse usually. Sometimes you measure your blood pressure once. Well, if you actually measure your blood pressure 3 times in a row, you see that there are variabilities and there are changes for a variety of reasons. We don't understand the dynamics of these data that are so important in order to be able to interpret it.
Very true.
And the last thing about this is that the doctor usually sees you, the clinician sees you when you're sick. And then they never have actually seen you when you were healthy, really.
That's true.
Or if you very seldom go to check up, right? And the doctor says, well, let's try this, right? And then come back if it doesn't work. Well, the doctor is doing experiment on you. It's the only time that you have no control conditions.
That's true.
So that's a problem that we are trying to solve.
So what do you think are the industry expectations? What are the industry expectations from us being researchers in this field?
I think there are huge expectations, but I think we have to moderate the kind of conclusions we are going to make immediately, because it's very easy to discover false relationships. Not that they would be false, but they are not causal. So, for instance,
the variability.
Well, there's one thing, but if you do analysis on purchasing, what people purchase, you will discover that diapers and beer are very highly correlated. So if you were just an official that would try to stop people from getting drunk, you would say, well, let's stop selling diapers.
That's true.
Right? And what happens is that both items are bought on Fridays. People stock up on
Friday. Yeah.
And there are a lot of things like that. And in order to understand it, so this is obvious, right? But there are some much more subtle relationships.
That makes sense. Well, thank you so much for your time and coming to this conference. It was a
It was a
pleasure to
pleasure.
meet you.